A horizontal asymptote is a horizontal line in which a function gets closer and closer to, but does not touch, as the function goes off to infinity or negative infinity. A quick way of finding a horizontal asymptote is to look at the highest power of x in the numerator and the highest power of x in the denominator, and only look at those terms. They are the most powerful terms in the function as far as the most powerful term in the numerator and the most powerful in the denominator, so they'll determine what happens as x gets larger and larger or smaller and smaller. If I reduce this fraction to 1 over x, I then analyze what happens as x gets bigger and bigger. As x gets bigger and bigger, 1 divided by a bigger and bigger number is going to get smaller and smaller, or it's going to go towards 0. As x gets bigger and bigger, as x goes off to infinity, or negative infinity. That means that my horizontal asymptote will be the line y equals 0. Let's look at a graph of this function. Here's a graph of the function, and if you notice, we have we can imagine somewhat a horizontal line running along the x-axis, in which the left side of the curve gets closer and closer to but doesn't touch. The right hand side of the curve is actually crossing over the x-axis at about 2 or so, and then it comes down closer and closer as we go off to infinity, closer and closer to the x-axis. The graphing calculator and graphing calculator software can be very helpful to somewhat see this, but the algebra shows exactly what's happening. Let's look at another example. Once again, let's look at the highest power of x in the numerator and the term with the highest power of x in the denominator, and reduce that fraction. This fraction reduces down to 1, so I should have a horizontal asymptote at y equals 1. Let's look at an example of this, or a graph of this. Here's the graph of that function. You should be able to imagine a line somewhat at y equals 1 that the graph gets closer and closer to but doesn't touch. Again, the graph could be a little bit deceptive because of the resolution. Notice also that the graph can cross the horizontal asymptote somewhere, but yet we are looking at what happens as we get off to the infinities. And as we get closer to the infinities, the curve gets closer and closer to that horizontal line. Let's look at another example. Once again, look at the highest power of x in the numerator and the denominator. If we reduce this fraction, we end up with 4x. If we analyze what happens as x gets bigger and bigger, 4 times that number will get bigger and bigger, so the value of y is going off to infinity as x gets bigger and bigger. That means that we have no horizontal asymptote. It means that we actually have what's called an oblique asymptote, but we won't get into that in this lesson. Let's look at a graph of this function. Here's the function. Notice you probably can't imagine any kind of horizontal line that the curve gets closer and closer to at the infinities, but you might notice a slanted line that the graph gets closer and closer to somewhere on the curve. That would be the oblique asymptote. Let's look at another example. Actually, a practice problem for you. pause the video, determine the horizontal asymptote, and then come back to the video to check your answer. In this problem, if we take the highest power of x in the numerator and the denominator and reduce the fraction, we have 3 over x. If we analyze what happens as x gets larger and larger, 3 divided by that larger and larger number gets smaller and smaller. So y is getting closer and closer to 0. I would have a horizontal asymptote at y equals 0. Looking at a graph of this, once again, you might be able to imagine a horizontal line along the x-axis that the graph looks like, the curve looks like it's getting closer and closer to, but not touching. And one more practice problem for you. Once again, pause the video, determine the horizontal asymptote, if any, and then come back to the video to check your answer. If we look at the highest powers of x in the numerator and denominator and reduce that fraction, it reduces to 2, which means we have a horizontal asymptote at y equals 2. If we look at a graph of this function, you might be able to imagine a horizontal line running at y equals 2, in which the curve gets closer and closer to but doesn't touch. Once again, this can be deceptive because of the resolution of the graphing calculator or the calculator software, but yet it does give us an idea of what the horizontal asymptote looks like. So again, to determine the horizontal asymptote of a function, we can look just at the highest powers of x in the numerator and denominator, reduce the fraction, and analyze what happens as x gets larger and larger or smaller and smaller.